Assalamu alaikum guys, I am ARK. In the previous video we have learned about membership operators and identity operators, and after that the topic we need to discuss is the bitwise operators. That is the last set of operators we have in Python or any other programming language. But bitwise operators operate on bits, that is binary digits. Therefore, to understand the working of bitwise operators, we first need to know the concept of bits. Let's get started by understanding what is binary number systems and what are binary digits. Now let's first understand number systems and what are the different types of number systems we have. So basically we have four types of number systems, that is binary, octal, decimal and hexadecimal. Each number system is divided based on the maximum numbers it can use. In binary we can use maximum 2 numbers, that is why its base is 2. So we can use maximum 2 numbers, that is 0 and 1. In octal, you can use 8 numbers, that is 0, 1, 2, 3, 4, 5, 6, 7. These 8 numbers can be used. There is no number beyond 7 in octal number system. And if we need to represent 8, we need to write 1, 0. And in our decimal number systems, which is widely used, which is taught to children from the beginning, we can use 10 numbers, that is 0 to 9. And if we want to represent a digit after 9, we need to write 1, 0. That is to represent 10. And in hexadecimal we can use 16 digits. Alphabets are also included. So these are the number systems we can use. And now let's understand what is binary number system. So the term binary means having two descendants. Binary means a thing which can be divided into two parts. So in our case, numbers in binary world, in binary universe can be divided into two parts, that is 0 and 1. Like people are divided into two categories, that is programmers and non-programmers. As we've seen in the previous slides, decimals have base 10. That is because we can use maximum 10 numbers in decimals, and binary digits, that is bits, can have base 2 because we can maximally use 2 digits in binary. So when we compare binary to decimal, 0 can be represented as 0 and 1 can be represented as 1. But to represent 2, we have to write 1, 0 because we have already used two numbers that are possible in binary digits, that are 0 and 1, to represent 0 and 1. But to represent 2, we have to use the combination of both, that is 1, 0. We'll see how it works. So a single binary digit is known as a bit, and if we write 8 bits side by side, it will become a 8-bit binary number. Now let's see how we can represent decimal numbers into binary numbers. To understand that, let's convert 10, the decimal number 10, to binary number. So in order to do that, we need to first check which number in powers of 2 is 10 closest. That means we need to represent 2 power 0, 2 power 1, 2 power 2 and all those powers of 2. And we need to check our target number is closest to which power. So in our case, 10 is closest to 8 and the number should be lesser than our target number. So 10 is the closest to 8. So we will write 1 here above 2 power 3 because 2 power 3 is equals to 8. So after writing 1 on 8 is satisfied, that is 8 numbers are deducted. Now we are left with 2. So we should check our remaining number is closest to what power of 2. In our case, 2 is left and we directly have the value of 2 as 2 power 1. So we will write 1 here. So 10 is satisfied, that is 8 plus 2 is equals to 10. And we can write zeros in rest of the all places. Actually I don't have the writing tablet, so my handwriting on PC is terrible. Please ignore that. So in simple words, 10 can be represented as 0, 0, 0, 0, 1, 0, 1, 0 in 8-bit binary. So this way we can convert decimal numbers into binary numbers. We need to check which is the closest one in the powers of 2 and then so on. We need to just keep on doing that, and finally we will be in a state that after we add the numbers on which we have marked 1, we will get our resultant number. Let's have another example. Let's this time convert 15 into binary. Let's first clear the frame, and we need to convert 15. So the closest number to 15 and lesser than 15 is 8. So we will write first 8 1 on 8, and after that, after we subtract 8 from 15, we are left with 7. So the closest but lesser number to 7 is 4. So we will write 1 on 4. So 8 plus 4 is 12. We are left with 3. The closest but smaller number to 3 is 2, and we will write 1 on 2. So we have written 8, 4, 2. That means 8 plus 4 plus 2 is 14, and we are left with 1. So 2 power 0 is 1. We will write 1 on 1. So 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 1 is 15. So 15 in binary digits can be represented as 0, 0, 0, 0, 1, 1, 1, 1. Hope the representation of decimal numbers to binary numbers is clear. So that is it for the video, guys. In next video we will see what are the operations we can perform on binary digits using programming. So